In 1945, a Hungarian-American mathematician published a book that would change how the world thinks about problem solving. The book wasn't filled with advanced formulas or complex theories. Instead, it contained something far more valuable, a simple four-step method that could be applied to virtually any problem, mathematical or otherwise. The mathematician was George Polya, and his book, How to Solve It, became one of the most influential books on mathematics ever written, selling over 1 million copies and translated into 17 languages. Today, we're learning the method that transformed problem-solving from mysterious art into teachable skill. Welcome to Maths Whisperer. I'm your host, and today we're mastering Polya's four-step method, a framework so powerful that once you understand it, you'll never approach problems the same way again. George Polya was born in Budapest in 1887. After studying mathematics across Europe, he eventually settled at Stanford University, where he became famous not just for his mathematical research, but for his teaching. Students loved his classes because he didn't just show them solutions, he taught them how to think. Polya noticed something disturbing. Students could memorize formulas and follow procedures, but when faced with unfamiliar problems, they froze. They hadn't learned to problem solve, they'd learned to pattern match. When problems didn't fit familiar templates, they had no strategy. So Polya systematically studied expert problem solvers. He watched mathematicians work. He analyzed his own thinking process. He identified common patterns in successful problem solving. And he distilled everything into 4 clear steps that anyone could learn and apply. The beauty of Polya's method is its universality. It works for mathematical problems, but also for scientific questions, engineering challenges, business decisions, and everyday dilemmas. The 4 steps are: understand the problem, devise a plan, carry out the plan, and look back. Let's explore each step deeply, because understanding them transforms you from someone who occasionally stumbles into solutions into someone who systematically conquers problems. Step 1. Understand the problem. This sounds obvious, but most people skip this step. They see a problem and immediately start calculating or guessing solutions. Polya insisted, you cannot solve a problem you don't fully understand. Understanding means more than reading the problem. It means engaging with it deeply. Polya suggested asking specific questions. What is the unknown? What are you trying to find? What data do you have? What conditions must be satisfied? Can you restate the problem in your own words? Can you draw a picture or diagram? Let me give you an example. Suppose the problem is, a farmer has chickens and cows. If there are 50 heads and 140 legs total, how many chickens and how many cows are there? Most students immediately start writing equations, but Polya would say, stop, understand first. What do we know? Each chicken has 1 head and 2 legs. Each cow has 1 head and 4 legs. We have 50 animals total, 50 heads. Those animals have 140 legs combined. We want to find how many of each animal. Draw a picture if it helps. Visualize the barnyard. This isn't wasting time, it's investing time in comprehension that will pay. Dividends later. Ask yourself, does this make sense? If all 50 animals were chickens, we'd have 100 legs. If all were cows, we'd have 200 legs. We have 140, which is between these extremes, so we need some of each. Good, the problem is consistent. This understanding phase often reveals insights that make solving easier. It also catches errors early. Many unsolvable problems result from misunderstanding what's being asked. Step 2. Devise a plan once you understand the problem, you need a strategy for solving it. Polya identified dozens of problem-solving strategies, but here are the most powerful. Look for patterns. Is this problem similar to others you've solved? Can you use the same approach? Our chicken and cow problem is a system of equations problem if you've learned algebra, or a guess and check systematically problem if you haven't. Simplify the problem. If the problem seems too hard, solve an easier version first. What if there were only 10 heads instead of 50? Could you solve that? Sometimes solving simplified versions reveals the method for the full problem. Break it into parts. Can you divide the problem into smaller, manageable pieces? Solve each piece separately, then combine solutions. Work backward. Sometimes it's easier to start from the desired end result and trace backward to the beginning. Try specific cases. Instead of solving generally, try specific numbers and look for patterns. What if there were 10 chickens and 40 cows? What would that give you? Testing specific cases builds intuition. Use different representations. Can you express the problem as an equation, a graph, a table, a diagram? Different representations reveal different aspects of the problem. For our animal problem, let's devise a plan. We'll use algebra. Let C your number of chickens, V your number of cows. I'm using VE for cows to avoid confusion with C. We know C plus V your 50, total heads, and 2C plus 4V, 140, total legs. Now, we have a system of equations to solve. Or if we don't know algebra yet, we could guess and check systematically. Start with 25 of each. That gives 50 heads, good, and 150 legs, too many. So we have too many cows. Try 30 chickens and 20 cows. Both plans work. The point is having a plan before diving into calculations. Step 3. Carry out the plan. Now execute your strategy. This is where most people spend most of their time, but notice it's only step 3 of 4. If you've done steps 1 and 2, well, this step is often straightforward. As you carry out your plan, Pólya emphasized, be patient and persistent. If one approach isn't working, don't give up on the problem. Return to step 2 and try a different plan. Problem solving isn't linear. You might cycle through the steps multiple times. For our animal problem, if we use algebra, from equation 1, C equals 50, V substitute into equation 2, 250, V plus 4V equals 140, simplify 100, 2V plus 4V equals 140, combine 100 plus 2V equals 140, solve 2V equals 40. So V trash 20. Therefore, there are 20 cows and 30 chickens. Check your work as you go. After each major step, verify that what you've done makes sense. This catches errors before they compound. Step 4. Look back. This is the step most people skip, and it's tragically wasteful. Looking back transforms a single solved problem into a learning experience that helps you solve future problems. Polya suggested several looking back activities. Check the result. Does your answer make sense? For our problem, 30 chickens and 20. Cows give us 50 heads, correct? And 60 plus 80, 140 legs, correct? The answer works. Is there another way? Could you have solved this differently? What if you'd used the guess and check method instead of algebra? Seeing multiple solution paths deepens understanding. Can you use the result? Will this solution method help with other problems? Yes. Any problem involving two unknowns and two conditions can be solved with similar techniques. Can you generalize? What if there were 100 heads? Or what if we added horses with 4 legs? How would the method adapt? Generalizing makes the method more powerful. This looking back phase is where learning happens. You're not just solving one problem, you're building problem-solving expertise that transfers to future challenges. Applying Polya's method beyond mathematics, the beauty of this framework is its universality. Let's apply it to a real-world problem. My startup is losing customers. What should I do? Step 1. Understand. What exactly do we mean by losing customers? Is retention rate dropping? Are new sign-ups declining? Both. How much and over what time frame? What customer segments are leaving? What data do we have? Get specific. Vague understanding leads to vague solutions. Step 2. Devise a plan. Can we survey departing customers, analyze usage data, compare to competitors, look for patterns in who's leaving? Perhaps we'll interview 10 recent churners, analyze usage data for 100 customers, and benchmark against industry standards. Step 3. Carry out the plan. Conduct the interviews, run the data analysis, gather the information systematically. Step 4. Look back. What did we learn? Does one issue dominate, or are there multiple factors? Can we fix this? How will we measure improvement? What broader lessons apply to customer retention generally? The framework works because it's fundamentally about clear thinking. Understand before acting, plan before executing, execute systematically, and reflect to improve. Common pitfalls and how to avoid them. Pitfall 1. Skipping to calculations without understanding. Fix. Force yourself to restate the problem in your own words before starting. Pitfall 2. Getting stuck and giving up. Fix. Return to step 2 and try a completely different approach. Pitfall 3. Not checking your work. Fix. Always verify your answer makes sense in the original problem context. Pitfall 4. Forgetting to look back. Fix. Make reflection a habit. After solving any problem, spend 2 minutes asking, what did I learn? How can I use this again? Teaching problem solving to others. If you're teaching mathematics or mentoring others, Polya's method is invaluable. Instead of showing solutions, ask the 4-step questions. Do you understand what's being asked? Have you seen anything similar before? Can you think of a simpler related problem? Does your answer make sense? These questions teach the thinking process, not just the answer. Building your problem-solving ability, like any skill, problem-solving improves with practice. Here's how to develop it. Practice deliberately. Don't just solve problems, practice applying Polya's method consciously. Force yourself through all 4 steps. Solve varied problems. Don't just practice one type. Diverse problems build flexible thinking. Study solutions. When you see elegant solutions, analyze them through Polya's framework. Which strategies did they use? Why did those work? Reflect systematically. Keep a problem-solving journal. After solving problems, write what strategies worked, what didn't, and what you learned. Embrace struggle. Difficulty is where learning happens. When stuck, resist. Looking up answers immediately. Struggle builds problem-solving muscles. The lasting impact Polya's method has influenced education worldwide. Modern problem-solving frameworks in business, engineering, and design thinking all echo his 4-step structure. Understand, plan, execute, reflect. The method endures because it captures something fundamental about how humans solve problems effectively. It provides structure without being rigid, guidance without being prescriptive. When you internalize Polya's method, you gain confidence. Unfamiliar problems become less intimidating because you have a process. You know where to start, how to proceed, and how to learn from the experience. George Polya taught us that problem solving isn't a mysterious gift. It's a skill built through systematic application of proven strategies. His 4 steps provide the framework. Your practice and persistence provide the mastery. The next time you face a challenging problem, remember, understand it fully. Devise a clear plan, carry it out patiently, look back and learn. These 4 steps, consistently applied, will transform how you approach not just mathematics, but any challenge life presents. Subscribe to Maths Whisperer for more frameworks that make mathematics and problem-solving accessible. Tomorrow, mathematical creativity. Where do new ideas come from, and how can you develop your creative mathematical thinking? Hit subscribe and comment. What's the hardest problem you've ever solved, and how did you approach it? Let's learn from each other's problem-solving journeys.